Okay, hello everyone. So today we're going to be working on math. So today we're going to be working on math. If you guys want to grab your math packets, these ones, like the fireworks, and then turn to page 4. So today we're going to be starting a little bit on trigonometry. And then we'll be working with, if you see like the second heading, we're going to be working with SOHCAHTOA and some other trigonometry rules. Okay. Alright, so basically what trigonometry is the study of the relationships between the sides and angles of triangles. So today we're going to start off talking about right triangles, and we're going to do something called SOHCAHTOA. So it looks like this. Have you guys heard of it before? SOHCAHTOA. Maybe, maybe not. Okay, well that's what we're going to be working with today. So let me start off by drawing a right triangle. Okay, so here's my right triangle. These two sides are the legs, and then we know that the side across from the right angle is called the hypotenuse, so I'm going to label that. Okay, so with SOHCAHTOA, the trigonometry that deals with something called sine, cosine, and tangent. So I'm going to write these all out for you. Sine is spelled S-I-N-E. Cosine is like sine but with a co in front. And then tangent is spelled T-A-N-G-E-N-T. So SOHCAHTOA deals with these three ratios, sine, cosine, and tangent. So let's say, with my right triangle, let's say I'm dealing with an angle right here. It's a cute angle down here, and I'm going to call it theta, which is represented by that little symbol. That doesn't really matter to us much, but this is the angle we're dealing with. So if I'm looking at this angle, which side on the triangle would be opposite from the angle? You guys know? Okay, so like opposite would be over here, like all the way over here. This side would be opposite from that angle. So I'm going to label it, because we're talking in regards to this angle, I'm going to label this the opposite side. Okay, and then this last side down here, technically in regards to this angle, it's kind of like adjacent or like next to, which is what adjacent means. So this side in comparison to the angle is adjacent. This side in comparison to the angle is like opposite of it. And then again, the hypotenuse is always the hypotenuse, which is across from our right angle. Okay, so if we're looking, so back to the sine, cosine, tangent thing. Sine deals with the opposite and over the hypotenuse in regards to like any angle of our triangle. Cosine deals with adjacent over hypotenuse, and tangent deals with opposite over adjacent. So back to our SOHCAHTOA thing, if you notice the S stands for sine, and then the OH is opposite and hypotenuse. So sine is opposite over hypotenuse. With the the C stands for cosine, the A is adjacent, and the H is hypotenuse, and then tangent T stands for tangent, O is opposite, and then A is adjacent. So this SOHCAHTOA is kind of like a way to remember these ratios when we're dealing with like trigonometry. Okay, so do you guys, any of you guys need this still up here? No. Okay, so I'm going to erase all of this, and then I'll write our SOHCAHTOA up there again when we do some practice problems. Okay, so again, I'm gonna draw a triangle, but now we're gonna actually throw some numbers in. So, okay, so here's my right triangle, ABC. We've got 3 side lengths. This bottom one's 15, hypotenuse is 17, and then this side length is 8. And so what we're gonna do is find the sine, cosine, and tangent of angle A. So this angle. So if I'm looking for the sine of angle A, I just label it like this, sine of A. And so remember, looking at our SOHCAHTOA, sine was opposite over hypotenuse. So looking at angle A, the side length that's opposite from it is this one. And so it has a value of 8. So that's going to go on top of my fraction. And then that hypotenuse is always that same, the longest side, which is 17. So that's it. That's my answer. Sine of A is 8 over 17. Okay, we're going to do cosine and tangent of A. Do you guys know what cosine of A would be?
15 over 17.
Yep. And then what about tangent of A? Okay, so pretty simple. You don't have to do like any math, just make fractions. Okay, let's do one more example. Okay, we're going to stick with angle A again. But does someone want to tell me what sine of A would be?
Would it be 4 square root 2 over 9?
Yep. So opposite of A is this side, 4 square root 2. And then our hypotenuse across from the right angle is 9. Okay, what about cosine in regards to angle A?
7 over 9.
And then tangent?
4 square root 2 over 7.
Yep. 4 square root 2 over 7. Okay, does anyone have any questions about how we got that? No? Okay, so moving on. We're going to do some more math. Okay, so does everyone have their calculator with them? One of these. Okay, so before we start, like type anything in, I want you to turn it on and then press like that mode button, which is right next to the second button. And make sure your calculator is in degree mode. Okay, does anyone have any questions about how we do that? No? Okay, so it does matter that our calculator will be in degree mode so we can get the correct answers when we're dealing with SOHCAHTOA. So hopefully everyone's calculator is in degree mode so we can get the right answers. But now we're going to do a little bit of math. So this you don't really have to do anything. Say on the ACT they just ask you like, what is sine of 10 degrees? So you like could do math or whatever, or you can just use your calculator because you get to use it. So just press like the sine button, which is in the second column, on the fourth one down. Press sign and then type in 10. You can close the parentheses and then press enter. And you should get 0.174 rounded to the third decimal spot. But did everyone get that answer? Okay, so if you got that answer, then your calculator is in the right mode, so that's good. Alright, so if they give you this question on the ACT, it's really super simple. You could do it in like 3 seconds. You just need to type it in, and then whatever it gets out, that's your answer. Okay, we'll do one more to make sure everyone's calculator is working, but what if I asked you cosine of 63 degrees? And then do you want to round to the third decimal place? Does someone want to just yell out an answer?
454.
Yep, 0.454. Yep. Okay, so that's super simple. We don't really need to spend a lot of time on that, so we'll move on. But now we're going to be using our calculator with actual triangles. Okay, so say we have like this triangle, and I ask you, what does x equal? So we don't know, right? It's like a variable. But we're going to use SOHCAHTOA to figure it out. So in regards to, because they gave us this angle 54, they didn't give us this one, so we can't use it. And then there's always that right angle that we need to be able to use it. So in regards to angle 54, what side is x? Is it the opposite? Is it the hypotenuse? Or is it the adjacent side?
It's the adjacent.
Yeah. So we know that we're going to have to use an A. Okay. And then if we're going to use another side length, we can either use 17 or W. Well, we don't know W, so we're going to want to use 17. So what is that side 17 in regards to angle 54? Is it the opposite, hypotenuse, or adjacent? Yep. So A and H. Okay, if we're going to use A and H, would we use sine, cosine, or tangent? Yep. So that fits. So now let's set up our equation. So if we're looking at for the cosine of angle 54, because we do know the angle, remember that was equal to adjacent over hypotenuse, so adjacent is x, and our hypotenuse is 17. So now that we've got this equation, we're going to solve for x. So to get x alone, I'm going to multiply by 17 on both sides. And so then x equals, if you want to type in your calculator, 17 times cosine of 54. And then what do you guys get?
9.99.
Yep. So 9.99. Did everyone get that? Okay, so now we know what x is. We're actually going to solve for w. I'm going to erase this work. Okay, so in regards to angle 54, what is that w side? Is it opposite, adjacent, or hypotenuse?
Opposite.
Yep, opposite. And then again, we're going to use 17 because that's the only other one we know for sure. So that was the hypotenuse. Okay, so we're going to use O and H. Which one are we going to use? Yep. Okay, so I'm going to have you guys try and set up the equation yourself and then tell me and then solve for W. Oh, hold on. Actually, I'll do this one with you guys. Okay, so sine of 54 degrees is equal to opposite W over hypotenuse 17. Okay, so then we'll multiply by 17 on both sides. And so then what does W equal?
13.75.
Yeah, 13.75. Okay, does anyone have any questions about how we got there? No? Alright, so we're going to do another example, and I'll have you guys try this one on your own. I'll just draw it up here. Okay, so here's my right triangle. We know one side length, this is a 7. And then x and w. So I want you guys to solve for x and w using our SOHCAHTOA rules. So remember the only angle they gave us is 28, so we're going to be solving it in regards to angle 28. Okay, I'm going to start writing the work up here, so you guys can follow along if you're done. Or you can keep working if you're not. Okay, so for side length W, you should have gotten like around 13.17 with rounding. So what I did is I used tangent of angle 28, which is the opposite over adjacent. Opposite I knew was 7, and my adjacent side we didn't know, so 7 over W. To get W alone, I multiplied by W on both sides, and then divided by tangent of 28 degrees, and so that gave me W equals 13.17. Have you guys finished solving for X? Does anyone want to let me know what you got?
14.91.
Yeah. So X equals 14.91. Okay, does anyone want me to go over how you would find X? No? Okay. So I'll leave this work up here for a couple seconds. Okay, so now we're going to try another triangle, except instead of solving for the side lengths, we're actually going to use the side lengths to solve for the angle. Okay, so here's my right triangle, HBX. We know that this side is 6. The hypotenuse has a value of 10, and then don't know this one, and we're looking for that angle down there. So even though we don't know this angle, in regards to in regards to this angle that we don't know, this side would be the opposite, so we're never going to use an O. And then this side is the hypotenuse. That's H. Okay, so O and H means we're going to use sine. So how I'd set up my equation look like sine of angle X is what I'm going to call it, and so we don't know it yet, equals opposite over hypotenuse, which is 6 over 10. Okay. And so how we'd solve for x, we actually have to do something called inverse sine. So it looks like sine, and then there's like a little -1 up there to 6/10, and that equals x. So x equals, and so what happens in your calculator, if you look at the sine button, it's kind of like that different color above the sine button, so you have to press second sine, and then type in your fraction, which is 6/10, and you should get, oh, I typed it in wrong, so it was working. Okay. Okay, you should get 36.87. And so our answer is actually the value of the angle, so we'll need to make sure to label it in degrees. Okay, does anyone have any questions about this one? No? Okay, so I'll give you guys another one and you're going to try it on your own. Okay, so here's my triangle P2Y. This side length is 100 and this one is 41. So I'm going to have you guys use Sokoto to solve for that missing angle right there. Okay, I'll start doing the work on the board. So in regards to this angle, 41 is opposite, and then 100 is adjacent. We don't know the hypotenuse, so that means we're going to use tan. So tangent of, I'm going to call it x, is equal to 41/100. Okay, so we'll need to do our inverse tangent, which looks like this, equals x. And so x should be 22.29. Okay, so moving on, now we're going to do like an actual ACT problem. So I'm going to like write the whole thing on the board, which might take me a second, and then I'll give you A through E. So I'm going to have you guys solve it, and then like pick an answer choice. And then you're going to have to like use critical thinking skills because we didn't exactly do an example like it, but you should still be able to figure it out with what we've talked about. So just like give me a second to write this on the board. You guys can like take a short break, I guess. So hopefully you guys can see all of that, but I'll read it aloud just in case you can't see it, it's glare or something. So in the right triangle shown, this one over here, the length of AB is 8 units. Angle A measures 60 degrees. Sine of 60 degrees equals 0.866. Cosine of 60 degrees is roughly equal to 0.5, and then tangent of 60 degrees is roughly equal to 1.73. So approximately how many units long is side length BC to the nearest hundredth of a unit? And then there are 5 answer choices there. So A is 4, B is 4.61, C is 4.8, D is 6.93, and then E is 9.23. So I'm going to have you guys solve this and then choose an answer option. Okay, so if you solve for an answer, does someone just want to yell out like which one they think it is? No? Okay, so the answer is actually D, 6.93. And we're going to go over how you would get it. So basically, after all that information they gave us, what they're asking is how long is BC, and then like rounded to the nearest hundred. So BC is this side right here. So if we're gonna like set up an equation to solve for this side, in regards to angle 60, because that's the one they gave us, it would be the opposite side. So that's an O. And then the other side length that we do know is 8, which is the hypotenuse. So O and H, okay, so we're gonna use sine. So if I set up my equation, it would be sine of 60, because that's the angle we were talking about, is equal to my opposite, and I just call that like x, over hypotenuse is 8. Okay, so if we look at the problem closely, they actually told us, oh wait, let me multiply my 8 over first. So times 8 times 8. So x should be equal to 8 times sine of 60. And if you look at the problem, they actually told us that sine of 60 is 0.866. So what you're just going to have to do in your calculator is 0.866 times 8. And then you should get 6.93 928, which rounds to 6.93. And so all this other stuff in the problem, like cosine of 60 degrees is 0.5, and like, what else? Oh, tangent of 60 is 1.73. You don't even need that to find the correct answer. It's just there. So it could kind of like trip you up, but if you know what you're looking for, then you should be able to find your answer, which was D. Okay, that kind of makes sense? Yep, okay, so now we're going to do another one where we kind of didn't do like another ACT one. We didn't really do an exact example, but you should still be able to solve it. And then this one won't take me as long to write. Okay, so that's all good. Okay, so this one says, if sine of x is equal to 12 over 13, and cosine of x is equal to 5 over 13, then tangent of x equals, and so A through E, here are options for, or answer for A is 5 over 12, B is 7 over 13, C is 12 over 5, D is 17 over 13, and then E is 60 over 13. Okay, this one shouldn't take too long, so does someone want to like yell out an answer? It's actually C.
There is a student who's trying to join, it seems, but she got kicked out for some reason.
Oh.
Here you go. Sorry.
Oh, perfect. Thanks. Okay, the correct answer is C. And I'll show you guys how you would get it. So they told us, first thing they told us is that sine of x is 12 over 13. So remember, sine is opposite over hypotenuse. So if 12 is the opposite, I'm gonna use an O. So opposite is equal to 12, and then our hypotenuse is equal to 13. Okay, and then we still don't know adjacent. For cosine, it told us that cosine of x told us it was 5 over 13. So adjacent, cosine, remember, is adjacent over hypotenuse. So that means 5 is the adjacent value, and then again 13 is the value of the hypotenuse. So now they said, what is tangent of x? Okay, so remember, tangent was opposite over adjacent. So our opposite was 12. We figured that out, and then adjacent was 5. So using sine and cosine, we can find that tangent is 12 over 5, and so the answer choice is C. Okay, so one more like ACT one, and then this one's going to take me a while to write. Sorry. Okay, so sorry about my drawing skills, but I'll read the question out loud. So, from a hot air balloon, the angle between a radio antenna straight below and the base of the library downtown is 57 degrees. If the distance between the radio antenna and the library is 1.3 miles, how many miles high is the balloon? So here's like a little hot air balloon, and then that angle is 57 degrees. There's the antenna, there's my right angle, and then that is the library. Down here, the length is 1.3 miles, and so basically what you're looking for is the length of this side, that height. So A is 1.3 over sine of 57 degrees, B is 1.3 over cosine of 57 degrees, C is 1.3 over tangent of 57 degrees, D is 1.3 times sine of 57 degrees, and E is 1.3 times tangent of 57 degrees. Okay, I'm gonna start going over this one. So we're looking for the height right there, and then we do know that this angle is 57 degrees. Let's see, what else do we know? So we want to use this side length, which we don't know, and then this one, which is 1.3 miles. We don't want to use this one. We don't know, and we don't need to solve for it, so it doesn't matter. So in regards to 57 degrees, 1.3 is opposite, and this, which we don't know, is the adjacent. So that means we're going to use tangent. So if I'm going to set up my equation, tangent of 57 degrees is equal to opposite, which is 1.3, over my adjacent, we don't know, so I'm going to use an x there. So if I were to solve for x, this is like multiply by x on both sides, and then I'm actually going to divide by tangent 57 to get x alone. So like this whole thing divided by tangent of 57. So what x actually comes out to, even if we don't type anything in the calculator, is 1.3 over tangent of 57 degrees. And if we look at our answer choices, it matches answer choice C. So that would be our answer. Okay. So now we're going to move on to something called the law of sines. So let me erase this quick. Okay. So we use the law of sines to like solve triangles, but they don't need to be right triangles. So it's called law of sines. And then I'm actually gonna write what the law is. Sine of capital A over A equals sine B over B. And so my capital letters represent angles and the lowercase letters represent side lengths. So I'm going to show you guys an example. Let's say I have a triangle here. And again, I said I didn't need to be a right triangle. Okay. Oh, and I guess I should mention, so like that lowercase b represents the side length that is opposite from angle B. And I guess even though, oh, this is not degrees, sorry, centimeters. Okay, even though we know that this side length is 350 centimeters, we could also call it like side A. So lowercase a equals 350 centimeters. Okay, so I'm gonna use that. But we are solving for B. So if I were to set up my equation, sine of angle A, which we're going to use A for angle A, so that would be sine of 59 degrees over my lowercase a, which I said was the side opposite from it, which is 350. That would be equal to sine of B. Angle B is 38 degrees. And then the side length B, we don't know. So it'd be B there. So to solve for B, what I have to do is like cross multiply 350 times sine of 38. And then I divide it by sine of 59. And you should get in your calculators 251.39 centimeters. So that would be the value of side length B. Oh, sorry, it's kind of crooked. But did that make sense? How we got that? Okay, so we're going to do another example. Okay, so we're going to use our law of sines to solve for the side length of A. So because we're looking for A, we're actually going to use the angle A2. So that would be, if I was setting up my equation, that would be sine of 48 degrees over A, which is what we don't know. And then we need another angle side pair, which we have one with angle B and side B. So sine of 93 degrees over 15. Oh, this kind of looks like a 9. Sorry, that's an A. Okay, 15. So how we solve it, again, cross multiply and divide. So I do 15 times sine of 48 divided by sine of 93 to solve for A. So what do you guys get for A in your calculators?
11.16.
Yep. 11.16. And so that represents this side length. 11.16. Okay. Any questions on this one? No? Alright, so now instead of, we'll stop. Okay, we'll do one more. So now instead of finding the side length, we're gonna actually find the angle using the law of sines. So I'm gonna write it up here again, sorry. Okay, so. Okay, so let's say I'm looking for angle S. So if I were to set up my law of sines equation, I'll say sine of, so it's going to be sine of an angle and side pair. We know angle R and then side length R, so I'm going to write sine of 120 degrees over 18 is equal to, and then we were looking for angle S, which we don't know, so I'm just going to say sine of S. And then we do know its opposite side length, which is 11. Okay. So now if I were to type this in my calculator, or if I were to solve it, I'm still going to cross multiply. So 11 times sine of 120 degrees, and then divided by 18. So if you type that in your calculator, you'd get like a decimal 0.529. But that actually is our answer because, well, that's equal to sine of S. They equal each other. But we're actually looking for just angle S. So what you're going to have to do is press, we're going to have to do the inverse sign. So you press second sine, and then second, and then that like negative sign down at the bottom on the left of enter, or second or answer, I guess is what it says. Second answer, and then you press enter, and then you should get for angle S 31.95 degrees. Okay, did everyone get that? Sorry, my calculator explanation was kind of bad. But did everyone get that in their calculators? Okay. So we're going to stop there today. We went through like SOHCAHTOA, and then we got through this law of sines rule. So I'll let you guys have your break like 2 minutes early. But that's it for me today. You guys all signed up for the ACT?
Yeah.
Yeah?
Yes.
When are you taking it?
I think in June.
In June? Cool.